My name is Leonard Maketa. I'm from the University of Dar es Salaam, College of Engineering and Technology, Department of Water Resources Engineering. I'll be taking you through from the issue of flood risk reduction and management in Tanzania, as we'll be focusing the case study of the Dar es Salaam region. Just as a part of the introduction, that flooding is the integral part in the hydrological cycle. That is just occurring when the volume of water in the river and the other water bodies surpasses the capacity. So it's often due to heavy rain and maybe rapid snow melt and a combination of factors like land use, urbanization, land use change, urbanization. As we appreciate that the flood is it's still critical in many parts of the world, as Tanzania being part of it. Yes, it is imposing a lot of significant challenges in the urban areas. For example, here in Dar es Salaam, is due to the rapid growth. The population in the city has been is expanding. Yes, here is we want to appreciate this process of hydrological cycle as being that in short is just a water cycle, the water balancing in short. That after the rain, the whole process of condensation, then it comes along the stream flow. Some are being evaporated, infiltrated, then moved down to the river or runoff. Then after maybe it's being exposed to the water bodies, maybe these bigger water bodies like the ocean. Some are being taken with the plants, the uptake of the plants. Then will be taken up again through evaporation or transpiration, being condensed, then it form clouds. Then that cycle continues. As we getting the flood from here, that maybe the capacity of the river morphology, the threshold of the river to take, it is being exceeded, their flood comes. So our case study is Dar es Salaam. So let's understand, let's have a short history of Dar es Salaam. Yeah, it's been taken like 1950s. It was just these pictures were taken. It is being approximated maybe 1957. This map was created. As we see, many parts of Dar es Salaam that are people now, they are put there. It's human settlement now. We appreciate that by then it was like it was swamp, or it was the lake, or it was the riverway. So we see Lake Tandale. The attention here is for Lake Tandale, Lake Mwananyamala, Lake Magomeni, River Sinza. By then these were the water bodies, but right now is this area are the very, very urbanized area. They are the business area. They are the place that a lot of commercial issues are there and shops. The same, if you appreciate again the history, we see the old Dar es Salaam. Many parts of this, just say that the attention being the rice fields. And this rice fields area, right now, there are a lot of, there are settlements in short. These areas, they are settlements. You see a lot of Kigogo areas, you see many parts, you see Temeke here, we see the place in the Kinondoni, a lot of places where rice farms. As of now, that after some time, those areas, people developed those areas. People made the settlement in those areas. As the city expands, people saw the potential of converting those land to the human settlement, to the commercial areas. As we appreciate that a lot of floods are happening now. Here is to appreciate, here is Jangwani. But then if you see the map, this was the rice field. As we get a lot of challenges here, a lot of challenges we see, like to appreciate few, that a lot of distractions, people are being moved, especially here at Jangwani. People are being called to move. People are being told to move this area to go to other places. The loss of lives, interruption in communications. And this road is not passable during the heavy rain. This road is not passable. Yes, the health and health issues and hazardous. As we see this river Msimbazi in Dar es Salaam is passing through all the places at Vingunguti, taking all those effluent from abattoir, those places that they do butchery. So even this is it's an outfall, or it's a bigger drainage of most part. It's draining it's draining it's a large part of Dar es Salaam. This is the Msimbazi River. Yeah, as to see it is contaminating the fresh water, economic losses, as you have said, that it is stopping some of the activity to be done in the town and whatever. The places that were, as we see that the places that were rice fields, now we see the settlements, and this is what is happening when the rain hits heavily. So the drainage have been fully, the area has been fully. Yeah, so these challenges, I thought that it is being due to some issues. First is the climate change. We shall discuss it. The climate change is the pattern of the temperature, rain has changed. The peak rain has changed. Everything is changed. So it is being one. It can be one of the causes. Insufficient drainage of this infrastructure, as we see that River Msimbazi is one of the drainage. It's like it is 4 meter above mean sea level. Here where it's flat, 4 meter above mean sea level, and the slope there to the sea is very almost flat. So this draining facility, or this draining pathway, it is being insufficient to drain the water at a time, to drain the peak flood at a time. As we see again the urbanization, as we appreciate a large part of Tanzanians, they really like to stay in Dar es Salaam. For those who come to Dar es Salaam, they just they're being attracted to stay here. So it creates this issue of urbanization, and people see that there's a potential of staying here in terms of economic growth, connection, whatever. So the urbanization in the city is being phenomenal. So let's see engineers, what they have done so far, or the role of engineering, the struggle of engineering in the issue of to manage these floods. As we see that it's still playing a role, as people have just gone to the areas that maybe if the police could be there, maybe should not be developed. But again, it's already there. So what the engineering is struggling to do up to the role of engineering in general. That's it's a one that used to design these infrastructures. The engineering part is used to design these infrastructures. Conducting flood risk assessment and mapping. Yeah, the engineering part is also trying to map those areas that are prone to flooding, maybe to different scenarios that they will decide. Maybe the rain to rain in this extent, and it will flood in this extent. Again, is to create these reviews and departments. Maybe you see the flood is occurring when the river is being upon the threshold, is being the threshold is being reached to the river bank. So engineering is struggling to increase those river bank. So it's part of the process that to create this reviews and department. Also implementing flood zoning regulation, designing, maintaining drainage system is trying to reduce this flash flood and the flooding. The drainage system are there in town. The hydrologists are working with this drainage structure with hydraulic engineers. So to maintain and design is part of engineering. Building these reservoirs and flood storage is part of it. Unfortunately, here at the restaurant we don't have. Maybe, yeah, I think we don't have. But it's part of it in the flood control. Is it attenuate the peak? Is it attenuating the peak hydrograph? It is reducing that flash flood. It accommodates the flood that it releases in a regular way. So these reservoirs and storages, they are doing that. So constructing flood diversion, if that is an option, engineering playing that role to construct these flood diversion channels. Developing flood forecasting and warning system. So engineering again is still taking place here in the FUSE. It's called flood early warning system. Maybe to using this global data set, rainfall data set, they are being converted the rainfall runoff modeling to convert that rain, the forecasted, the projected rain, it is being converted into the runoff, the stream flow. Then it simulates how it will be appearing the next time. Then it gives the warning. Upgrading the building for flood resilience. That is part of engineering. We shall see how is being taken up. So the engineering part that is playing a great role is hydrology. Hydrology discipline is the one that is being used to improve or to design this drainage system, the flood modeling and prediction. I will just say and appreciated. That is simulate the coming rain, the weather, the climate that is being anticipated in the coming time. Then that data, whatever, they are being incorporated in the model. Then it simulate how the water and the distribution will be. So also the hydrology part in the erosion control, because as we see that as we allow this erosion, the riverbank erosion, it's going to seal the river. It is going to reduce the draining system. It is going to reduce the capacity of the river, and it is the watershed management, as we shall discuss in depth the issue of the watershed management. Again, in the floodplain management, it is zoning those places of floods. It's zoning those places that flood may occur. So maybe to restrict people or to restrict some of the projects to be there. Yeah, what is the ongoing effort here in Dar es Salaam, apart from designing all the drainage structures, putting some effort in the own these structures here and there. So let's the continuing effort now. As we appreciate that this is the project that is ongoing, I think it is yet to be spread. The issue of creating the Dar es Salaam flood dashboard. Maybe in the next time it will be done the whole country. But here it is just started this Tanzania Urban Resilience Program. They have started this creating this dashboard, the flooding, to map the whole Dar es Salaam, where will be the floods in maybe in 2028, in 2050, in 2075. So wherever you want to do a project or wherever you want to implement any development project, so you will go and see what is the flood extent, how is the place flooded or not, is the place prone to flooding or not. So this dashboard, we just give an awareness. So this is just a start. Maybe again they are going into detail that they check the risk, the flood, those anticipated flooding risk, maybe the number of household, number of people affected, the cost, the loss that you incur in terms of USD during depending on this flood extent. This flood extent, this loss that have been carrying, this flood extent to this number of people that are affected, this huge maybe to 2020, 2050, 2075, it is just being the projection. As we appreciate that the hydrology part is doing this flood forecasting modeling. So this is part of it. So that is one ongoing effort here in Dar es Salaam that they have started creating this. The publicity of this may be worldwide, or it will be under Tanzania Urban Resilience Program. Another thing is the ongoing effort here in Dar es Salaam is we appreciate that the area by then it was this was swampy, lakes, river. So now people have just made the settlements. A large part in Dar es Salaam now is better. So the training that World Bank Tanzania started or initiated is to think of appreciating or to adapt this sustainable urban drainage system. Of course, it's an approach to manage water runoff in urban areas in an environmentally sustainable and integrated manner. That from the vicinity that these floods are occurring, the management is starting there. Yeah, this I've appreciated some of the components of a sustainable urban drainage system. This hydrology are sustainable. They have tried to check some of them. So there are these infiltration basin, there are these detention ponds, there are soakaways, there are infiltration trenches, there are these pervious pavement, there are this bioretention area. So in short, this sustainable urban drainage system is trying to convert the watershed to the original part. People have destroyed the environment. People have just made the impervious ground. People have just put the pavement all over. So this sustainable urban drainage system is trying to see the possibility of introducing these SADS components here and there during in the design of this drainage system. So, for example, instead of putting a concrete drain, the bigger concrete drain, they are thinking maybe to put this the drain as it is, but incorporate those infiltration aiding components or aiding facilities, like to put the gravel, plant grasses, maybe to slow down the water. Then you give the chance to infiltrate down the ground. As you see, many of them, these component of sites, they are taking water, they are giving the time for this water to be infiltrated. As you see, if they are thinking maybe if these flash floods, they are being taken in somewhere, the detention pond, and allow there to evaporate or to infiltrate. It will be one of the help to incorporate if our paving have been given the spaces, maybe to allow the seepage in, instead of collecting and dumping and giving, joining another house, dumping, accumulating the water down there. So from the vicinity, from the start of these floods, from the start of this runoff, we are starting controlling from there. That was an idea. If we see they have this a green roof, instead of putting these iron sheets, instead of putting this impervious maybe roof, they are thinking maybe to incorporate the greenish in the roof. So if whenever the water impart there, the water got there is being absorbed, and just drained slowly, instead of being taken straight away to the runoff. They are thinking of having their infiltration trenches, if possible, infiltration basins. Yeah. Of course, again, to have the wetlands, to maintain the wetlands. Yeah, maybe they are at Simbazi in our case, maybe thinking to recreate, making that wetland work well for the flood control. So this is being appreciated, is being a continuous effort. Like these SATs should be part in the design, should be incorporated in the design, should be in the teaching, should be in the engineering. Those consultants firms doing this, those hydrologists, hydraulic engineers should think of incorporating this in the design. Anyway, maybe to have the great understanding of this component of SATs, there are these permeable surface, converting from putting pavings, putting the impervious surface, converting them to be permeable, maybe allowing some materials to allow water to seep in the ground. So you say using material like permeable paving or asphalt, that allow rainwater to infiltrate in the ground. There are these swales and ditches, constructing vegetated channels. Instead of putting a plain concrete or a stony, a lip lap, whatever. So thinking of putting the vegetated drain so that it reduces the speed of water and giving the water time to sit down, giving the water time to infiltrate. So that was an idea. Again, retention and detention basin, creating ponds or basin to hold and slowly release. The flood is just a matter of that water passing per that time. That in the other time the water may be not there, but when the heavy rain hits, that the flash water is passing that time, so that the destruction, whatever is happening at just that time. So they are thinking to have this detention or retention ponds that is hold water at the time that is it is being it attenuates the hydrogen, it reduces the tension of this water. So holding the water when the heavy rain hits, the runoff is high, then you're releasing them slowly as stormwater and preventing downstream flooding. Having the green roof, as we see, the roof are the very primary source of this runoff. As water hit the roof, it goes slowly. it goes down to the ground. So from there, when the rain water hits, it's being captured in the green. That was another idea. Rain gardens, to have the rain garden around, not just putting pavement in the house, just having the rain gardens whenever water being directed there. Filter trips, narrow vegetated that filter runoff before entering the water body can have. It's just like we put like gravels is in the water path before it is maybe in the bigger water body. We put like these porous filter strips, water to be taken, be infiltrated there. These are the goals or the purpose of this. You appreciate that the purpose of these SATs. First is to minimize the flood. As you see that it accommodates water, that flash flooding accommodated for some time, then it releases then it's flood. So that is minimizing the flood. Water quality, the issue of water quality. Is the water passing through the vegetation instead of pathing in just a concrete, taking all the waste, taking all the debris, taking all the thrown material there in the drainage. So it's just pathing in the vegetation. So the issue of water quality will be aided in that way. Again, is to enhance biodiversity. You say SATs incorporate green infrastructure element, permeable surface. It's creating the habitation of some of the microorganisms and some of the organisms. So this creating wetlands, creating this vegetation, nature. So it gives the room for the biodiversity. It gives the room and environment for the other organism, microorganism to live and to appreciate biodiversity as well. Again, it's in terms of aesthetics, amenity, the gardens, the greenish environment. It looks nice, recreation-wise. It looks nice in terms of looking. So the issue of aesthetic, amenity, benefit has been one of these purposes of these SATs. So the groundwater recharge again, as we give the room of that water to penetrate in the ground, we appreciate that ground will be recharged. The base flow, we aid the base flow. So SATs give the room, instead of allowing those water direct to the ocean, those storm water direct to the ocean. So trapping them and giving them the room to infiltrate in the ground, it will be good. It will be it can be used again. So one of the issues here in SATs is giving the room for groundwater recharge. In fact, let's see the comprehensive worldwide approach in the flood management. As you see that from the flood hub, they have developed this as this is a catchment management approach, that it can be one of the very best, just anywhere, can be thinking maybe some of the factors to be incorporated. So this is the bigger picture approach, developed by this the flood hub, the new ground community. We'll be having this as a water pathways. We'll be having this storage. Having this, the rural area is green. What does it mean? That first, when the rainwater hits, it's just being trapped, not this being bared. It's natural flood management, just like having this basin Of course, they say that the SATS drainage system, this urban, in terms of these storages, this is the SATS again. The storage areas, the agricultural land management, we say guys that they put this stripping, that whenever water hit there, whenever the water is being retained for some time. Again, we see the issue of aiding the drainage system to pass the water easily. Then say the gravel management, having this one, removing the gravel, removing the debris, removing the silt and sediment. You see this, so removing and helping the river to make the water pass easily. Again, the issue of monitoring. They are thinking maybe this is a bigger approach, like they have to put the monitoring, this gauge boards, the telemetry system. This will be giving feedback to the, this is the process, aiding the process, flood early warning system. This is help in the modeling, help in the prediction, help in the different research. So in the different flood research, this data here, so they are thinking of the picture that if we have this monitoring and telemetry, they can be incorporated in the FUSE system, flood early warning system. The data, we have to have the baseline data to accommodate, to see the quantity of water that is passing. So this monitoring instrument, they are the one measuring water here. So with time we'll be having the data of the quantity of water that is here. And then if the sediment also can be monitored here. If the sediment are reducing or increasing, if the flood is increasing or reducing, so this will give the answer. So this can be to appreciate all these efforts. How are they continuing well? How are they doing? How are they effective? Be seen here in the monitoring rate. Again, in the issue of the building, we say that to have the building being flood resilient, the building to be flood resilient. Yeah, to have we seen that we can have the green roof to tap the water, or if we can have the rainwater harvest system, it can work. Yeah, you can think of having a rainwater harvest system, having the basin around, or having the tanks around. So to tap the water there. So if you're not tapping that water, maybe to have this a green roof that will tap the water for some time and then just release it. Okay, in terms of community resilience, yeah, they can be to put the community being aware of the flood, to incorporate the community in the issue of flood mitigation, to incorporate the community to know that this step that we are these scientists and engineers and the experts are taking, the community to be part of it to help in the issue of flood management. Okay, the other issue is maintaining this highway, having roads with the good drainage, having roads to have very good drainage structures, very culvert, bridges, open channels, ditches, be well drained, well designed, so that it will not affect the community. So to appreciate the references, there are a few references that we go and take a path through. So the issue of drainage, the urban drainage here in Dar es Salaam, the history of the Dar es Salaam, the hydrology as well. Yeah, so these are a few references that we appreciate. There are many, but these are a few references to appreciate. So I welcome the discussion, comments, to have the views, to comment, to see where can we improve, where can we go about, where can we make our city safe in the flood.